I'm going to record today. I wanted to sort of take today and sort of, I guess, take a step back, because we've been doing a lot of like technical discussion on loads and everything, and I do sort of want to take a little bit of a break from that, because I want to make sure that everybody's okay with the project, in terms of the requirements for the class. And everybody sees the path moving forward. Okay. Now, I want to be absolutely clear that everything that I've been discussing in terms of loads and everything for the past few days, it is vitally necessary for the end of the project. You all have had me for enough of my courses, whether they be concrete design or steel design, to know that there's always two sides of the equation. There's the loads and the resistances. And so for the past few weeks, we've been sort of defining the loads portion. And I think we sort of have essentially finished that for the purposes of our class. There might be a couple of things that we need to tweak out in the end, but if you understand and are able to do what we've done up until now, then any tweaks or any additional things we need to throw in at the end, depending upon the options that you choose, will sort of, it'll be pretty easy to assess. See, at some point, the way that I move forward from here on out is going to kind of depend on you. Because if I have 5 groups and every group picks, let's say, a concrete bridge, I don't need to talk about steel anymore, right? Because, there's no point. I'm not going to sit here and waste my time and your time discussing how to design a steel bridge if nobody's picking that option, okay? But if I've got groups that are, if everybody picks the steel option, then that gauges me moving forward as well. Another thing that's worth mentioning is that what happens if I have a mix, which is honestly what I do expect to happen. What I expect to happen is I'm going to have some groups go with steel and some groups go with concrete. So let's talk about logistics moving forward with that. Let's say that happens, okay? If that happens, this is what's going to be the case when we come back from spring break. I'm probably going to devise a schedule that's going to go something like this. Mondays, I'm just picking this day just to give you kind of an idea, but let's say Mondays, the teams that pick the steel option will be just them, okay? And let's say Wednesdays are the teams that pick the concrete option. And so that when, let's say it's Mondays and I'm working with the steel bridge teams, we can have a much more detailed and directed discussion about where you need to go to finish things, okay? If you're a team that picked a concrete bridge and you're sitting here listening to me drone on about service to and fatigue and steel limit states, you're going to sit here and go, damn it, you're wasting my time. This isn't valuable to me, okay? And you're absolutely right. So what we'll probably do is we'll probably adopt a schedule when we come back from spring break that'll be something like that, where Mondays, and we can figure out whatever we think is appropriate, but Mondays, the steel bridge teams will meet, Wednesdays, the concrete bridge teams will meet, and then Friday, we might do something like everybody meets and we just discuss general project issues, or we might not meet at all because it might be that you all are rocking and rolling and working on your own. And then from week to week, maybe the steel bridge teams need more time. Maybe the concrete bridges teams need more time. I'm easy to get along with there. But does everybody kind of get an idea about that? All right. So what I'm getting at is we've kind of gotten to the point where we're running out of things to discuss that's completely independent of steel and concrete. We're sort of getting close to that, to where at some point a decision will need to be made, and that's where you all are at in your alternatives phase. And so what I'm getting at is, we're going to have some discussion today and some discussion on Friday about where you need to go in order to finish the alternatives phase. And then between now and let's say when you submit your alternatives report, there will probably be a few days that we quite frankly just don't meet because you all have got some work to do and you could be using this time to work, okay? And that's sort of like my general thoughts starting next week. But what I want to do is I want to use today and let's say Friday to sort of hash out some of those issues and make sure that everybody is clear on where they need to go throughout the final report. So just to sort of take a step back, you know, we've been talking about all these detail-oriented provisions about loads and DC1 and DC2 and all that. And that stuff has the potential to affect your alternative selection, but maybe not. You know, for instance, I know that there are teams that are evaluating their alternatives and going, none of this load stuff is worth a damn when it comes to my alternative selection because I have a bridge that's 150 feet long and I can only fit a girder this size, and so it doesn't matter what's going on with the loads. I'm sort of limited by that, and that's a possibility. Okay, I totally understand that. There are also teams that are going to say my bridge is so short that a steel option, at least based on the economics that I'm finding, is just not going to work. And so I kind of understand where that decision process would come, and I understand that none of this stuff might help your alternatives report at all. But it is going to go in your final report. And so I do want you to understand that, bless you, I do want you to understand that if I waited until after spring break to start explaining this, that would be one hell of a few weeks between spring break and the end, right? I just want to make sure everybody's clear that that kind of needed to be done now so that you understood what you needed to do in the spring break, because I don't like rushing that. So yeah, let me make sure though that I'm getting through a few logistical updates. So first off, I got everybody's minutes. I graded them. It also looked like from the last minutes that I had reviewed, or at least the last couple of minutes that I reviewed up until now, like I had started to see some names that were absent from some of the individual meetings, but I didn't really see that this time, so that's kind of a good thing. Maybe I missed something, and so so I'm happy about that. I went ahead also and I uploaded the live load envelopes, so I did finish that. So I do want to show you what that sheet looks like. So here's the sheet, okay, and if you look here on the bottom, there are 5 tabs, and those tabs correspond to each of the span lengths. So if you have, let's say, the 110-foot span, just click that, and there's everything that's filled up. Remember, I have every single thing calculated except for 2. I didn't do the strength limit state at the end, but that's pretty simple because it's just 1.25 times the DC, 1.5 times the DW, and 1.75 times this. So that's pretty simple. And I didn't do this because that's sort of me going, well, if you can do this part, you should be able to do this. I just wanted to see if that everybody is sort of following along. It's a very little mini pop quiz, but I want you to give it the old college try, and if you're having issues filling that in, let me know. And so I have this uploaded. I put it in the project description. So you know where there's the thing on course content that says the request for design services is at the very beginning, and it says, you know, you are to design this bridge and it will have these requirements. Y'all remember that? It's right there on course content, so everybody should have access to this. I also uploaded the last RFI response, or the response to the last RFI I got. And that one I've already discussed in class. I just hadn't gotten around to actually writing the response, but that was the one regarding the pier in the water. And what I said was, I had a group ask if they could include a pier in the water, and I said, well, yeah, but if you're going to do that, you have to start, you know, from scratch. I need the pier costs. I need, you know, like sort of everything that goes along with the pier. And so if you're going to include a pier, that's fine, but there's going to be a lot more to estimate in terms of costs. So I'm just putting that out there. So yeah. Okay. All right. Is everybody okay so far? Okay. So let me talk real quick about this team member evaluation thing. So I think I kind of mentioned this earlier on in the semester. Do you remember me mentioning the idea that you were going to evaluate yourself? Well, we're getting to the point where we actually need to start discussing that. I mean, the alternatives phase is nearing its end, not gearing up, okay? So by now, or at least, if not by now, at least between now and the next week or so, I think that you all are going to have a pretty good idea of how your team members and peers are contributing to your work, right? And if you don't have that idea by now, I would be surprised, but I imagine that if it's a little fuzzy, that's going to become clear real quick when you start actually putting together your report and your presentation, because then you'll know then who's your friend and who isn't, right? Right? I'm being facetious, but not really. So I wanted everybody to be aware of that. So just to make sure that everybody remembers how the sheet operates. So the sheet operates by, you put in team members' names. So, it might be Greg and Bill and Joe and Sam and all whatever. And then what you do, that wasn't you. So what you then do is, it's asking you questions like, did this team member accept a fair share of team responsibility when asked? So you can put in a little x or a big X, and it will compute accordingly. Now, if you think that the answer is, well, maybe it's not 5, maybe it's not 4, maybe it's 4.5, you can put in both, and it'll average the two, okay? And so all you need to do is put in, for each person on your team, fill this out. You can use a little x or a big X. It figures out both. And rate each of your team members, okay? Now, that's the first part of the evaluation. The second part of the evaluation is this. And so for each of those team members, you can see that I entered that there's really 3 more things that I'm asking. I'm asking 2 yes or no questions, like, would you like to work with this person again on future projects, and is this person competent in the design techniques? And so there's a drop down, yes or no. It's pretty simple. And then right here, this box is where I just want you to put anything that you think is worth saying. If they did great, put that. Put that they were at every meeting. Every time we needed something to get done, they got it done. Put that. If you have somebody who's never responded to emails, who's consistently late, who never produces, put that too. I'm not asking you to be vengeful. That's not what this is supposed to be. That's it's not a means of if you have a personal issue with somebody and it's like, well, I didn't like them. They called me a meanie, so I'm giving them a 0. I don't want it to. Did that happen? No, I don't want it to be that. I really don't want this to be vengeful, but I do want you to be honest, okay? This is a team experience, and so the way I look at it is this, is I've been in your shoes, okay? And I've been in group projects. I've been in high-stakes group projects where I've been in a team of 5 or 6 people, and there's 1 or 2 who just didn't do the work. I understand that, and what I don't want to have happen is this, is you're in a team experience and the professor expects that you've got 6 people, so everybody's contributing equally, and that doesn't happen. You only have 4 people contributing or 3 people contributing, and then when I look at the report, it's not where it was supposed to be. There's a reason for that, and the reason might be that you didn't have as much help as you were supposed to, and so I want to understand that. This is confidential, so it is between you and me. Nobody else sees it but you and me, okay? And so I want that to be absolutely crystal clear. Yes?
So the second question, like you finish up with the design.
Mm-hmm.
If you say no to that, does it hurt your grade?
Well, no. No, it doesn't hurt your grade. That part doesn't hurt your grade. And let's be clear, that's a good point because nobody in here had ASHTO LRFD bridge design before the course began. And there are still things to ASHTO LRFD bridge design that you don't understand. I am completely aware that nobody in here is going to be an expert in bridge design before they leave this classroom. That's never my intent. but you can leave this classroom knowing what is the difference between DC1 and DC2. You've heard of that stuff before. You know what a strength limit state is and a service limit state is. Let's also be clear. You go to a design firm, they're going to have software programs and routines that do a lot of this stuff for you. I'm no dummy. I'm been involved in creating some of those routines. I get it. But even with those tools, you have to sort of know the lingo. You have to sort of know the terminology. And so I'm putting you through the ringer, and I understand. It's sort of, the way I sort of think of it is sort of like a statistics class. Okay? You know how long it's been since I took the undergraduate statistics class? It's been a long time. And like many people who took statistics, you take statistics and it's 30 years from now. Do you really remember how to do a hypothesis test? Do you really remember how to do a lot of this like really complex stuff? Probably not. But do you know how to calculate a mean and a standard deviation and do a linear regression? You bet, because there are certain things that stick in your head. You probably don't remember every single little lecture out of Calculus 1, but I know everybody in here knows what the derivative of x squared is. You know what I mean? So that's sort of my goal with this class, is that I understand you're not going to pick up everything. I get it. And it is sort of a crash course in bridge engineering, but you're going to pick up enough to where you are going to have a competitive edge over your peers applying for the same job. Guaranteed. And that's my goal. So, so I understand it if you put no, and you're not going to hurt my feelings, but keep in mind that understanding just AASHTO LRFD it really is a small part of this project. And think about the work that you've done up until now. You've done document formatting. You've done, you had to act professionally in a team. You've had to have proper communication and able to get work done on time. You had to understand structural analysis. I know everybody understands that because, well, I hope you did, because if not, then I'm a total screw-up. You do understand the basics of undergrad concrete design and at least the steel design up until now. So don't sell yourself short either. You guys have a hell of a lot of experience coming into this. And I've had very legitimate questions. Like, I've never had somebody in here ask, well, how do I determine support reactions? Nobody's asking that. They're asking real questions about, do we have to consider the approach slab and consider this? Y'all get it, probably more than you think you do. I mean, don't sell yourself short. You all, this group as a whole so far has impressed me quite a bit. I've been doing this a long time, and I've had senior design experiences where I've had to drag them through the mud, kicking and screaming to get to where they need to get. That isn't the case with y'all, so don't sell yourself short either. Y'all doing really good, so I've been tickled so far. But I can but to go back to this, I could sort of see, I do want you to be honest. Let me say one other thing, and this might seem a little weird. I want you to evaluate yourself. I want to see your scores on yourself, okay? You could give yourself a perfect score. I think you did great, But I want to see your honest evaluation of yourself, okay? I do. One thing I do want to mention in terms of logistics, and I'm going to pause the video on this, and you'll see why. Okay, so I will fix that typo on team member 6 and then get back to you. I'll let you know. One thing I'll mention, the team member evaluations, I have them due in 2 weeks, okay? I want everybody clear on that deadline because the alternatives report is due Friday, March 15th, okay? So I wanted that to be turned in a little early. You could do it now, once I fix that. But I'm giving you time to do that, so, yeah. This, the report, it is turned in online. When you turn it in, you could turn I'm pretty sure the link is set up now, but if not, I'll check. You could turn it in now. I have it set up to receive unlimited submissions up until 5 p.m. on March 15th. So you could keep resubmitting and resubmitting to your heart's content if you think that's necessary. So that's fine. I have no issue with that. So. What's that? Do it now? Do it live? Do it live. Yes.
This could be a very simple question, and this could be a very topic. So, in terms of what we have as design alternatives for 110 feet, somewhat limited, but one of them that is a possibility is a rolled beam with a bolted extra piece on the tension flange,
A cover plate.
Right. So, in terms of pricing that out, looking through the book, you can't just say, hey, that's the one I'm going to use. Like, how do we know which roll beam that we need to actually price out?
If you don't mind me asking, I'm just trying to understand, is there a reason that you went with a rolled beam with a cover plate on top of it instead of just using a rolled beam? Like, why the need for the additional cover plate?
Because, if I'm not mistaken, according to, I want to say it's the West Virginia DOH Bridge Design Manual, that only goes to 100 feet is where the cutoff is for just the rolled beam. And
Those are recommended.
Okay.
That's a good point. Okay, so you should check that, but the verbiage, as I remember it, is this is where you should be considering it. But the key word is should be. Okay. The reason why they're specifying those options in those ranges is because traditionally those are about where you've got to consider things. And you'll notice that a lot of our span ranges overlap in those ranges. Like you should be considering rolled beams from this feet to this feet, but you should be considering bulb tees from this span to this span. It's funny how a lot of our spans interact. It's like I did that on purpose or something. I kind of did. But the key word is should be. What they're doing is they're trying to guide you towards selecting an alternative that makes sense. If you have a bridge that is 300 foot long, you should not be considering timber. That's sort of the point. I'm being facetious when I make that statement, but in seriousness, if your span is 110, then there are some options within that span range that you should be considering. And if you're not at least considering those options, then there's a problem. I have absolutely no problem at all if you say, yeah, we are evaluating these options, but we also want to look at this because we got an idea that this might be cheaper. That's completely fine. No issue with that at all.
So we can still consider a roll beam then?
Yeah. And you could, and
cover plate was my question, because it's like, how do we know right this second? Because I know where the cover plate would be placed. It's where your moments just exceed your whatever, but your loads. But the questioning, okay, so how thick do we make that, and where exactly do we put that right now? Things like that. And getting our alternative phase completed. Knowing how to go about that.
Bless you. You know enough now how to generate your MU, your factor, and you can use strength 1. As for a rolled beam with a deck on top of it, you should be able to, for the most part, figure out the strength of that beam. Okay. And if you want the really simple answer of how to figure out the strength of that beam, like the FEMN, a super rough and dirty but surprisingly accurate way of doing that is to treat it like it was reinforced concrete. You have a slab that's 8 inches thick and 10 foot wide, and then you have a lump of steel at the bottom that has a gross area and an FY, right? So remember ASFYD minus A over 2? You'd be surprised how well that would work, It will be a little off, I'll go ahead and tell you, but you'd be surprised how accurate it really is. What we do, just spoiler alert for later, when we look at a composite steel bridge, is we end up computing what's called a plastic moment. And that plastic moment helps us determine what the beam's capacity is. But the way that we determine the plastic moment and the way that we determine FEMN for a concrete beam is very similar. Like, let's go back. How did you do FEMN for a concrete beam? How did it work? Well, you have the tensile force, which is the area times Fy of your steel. Then you had the compressive force, which was 0.85 FC prime AB, right? And so B being the width and A being the depth of that stress block. And so what you would do is you would say, how deep does that stress block need to be such that compression equals tension, and then you'd sum moments to get M in. It's the same thing that you're doing with plastic moments. I mean, it's the exact same thing. So you could, if you had, okay, we're going to use W, what's your section? Or do you have a section?
Oh, we don't have a section yet.
Okay, let's say it's a W27 by 84. Go ahead and spoiler alert, it's not a W27 by 84 for a span of your size. Let's say it's a W27 by 84, right? So W27 by 84, you could figure out the area, you could figure out the yield stress. Here's your concrete deck, ASFYD minus A over 2 tells you your moment capacity, right? Okay, so what you could then do is you could go into your spreadsheet, right? And you all are at 110 foot, so get your dead load moments, get your live load moments, factor them, and plot them, right? And so you're going to have a plot that looks like this, right? There's your capacity. Plot the capacity right there. There's where you need your cover plate. You know what I mean? So that's a way of doing it. Now, how are you going to attach that cover plate?
Well, it says bolted. It says that it's bolted with, you know, there is welding to it.
Well,
You can probably just, you know, on the side that would say it.
well, don't put welds on the end.
Yeah.
Don't.
Yeah, I think actually it shows a cutoff of like from here on.
The reason
A section that you do not.
The reason why is, for your curiosity, the reason why is because of fatigue. There are certain ways in which, you know, you have a beam and you've got, you know, members connecting here and members connecting there and things bolted and things welded. And so certain configurations of bolts and welds and connections are going to behave better in fatigue than others. And a end welded cover plate is the worst fatigue detail that there is. There was a case called a failure called the yellow Millpond bridge. Let me see if I can find an image of it, because this is actually kind of important. Nobody uses it.
Would that voltage connection on the bottom kind of cover where our splice is at?
Not necessarily. But let me say this, what I would probably do, that's a good question, I would probably do your best to try and move the splice away from the cover plate, because you got a lot going on there. That would be me. But yeah, this is what happened on Yellow Millpond. So that's the cover plate, that's that end termination, and that's a crack going right through the girder. So don't do that. So. Yeah, they actually completely revised how fatigue behaved as a result of that. Like, these are fatigue cracks. That's.
Would you actually consider putting, would your bolting, would the exact size of your plate basically be right where that capacity is with your moment?
I'd extend it out a little bit.
Yeah, I was gonna say.
I'd extend it out so it overlaps a little bit.
Okay.
In the area of that plate is staying up movements.
Yep. Yep, exactly right, exactly right. And so you could do the same thing like when you're doing MN, just add that steel, you know what I mean? Mm-hmm. You know, because you just have another area and another distance. So that's exactly it. I would probably, what I would do to facilitate the construction is I would make the plate the same width as the flange. And so ultimately what you're solving for is the thickness. Exactly right. Something like, yeah. I wouldn't select a 1964-inch thick plate. And you're thinking, well, nobody would ever do that. You'd be surprised how some bridge engineers would. So, yeah. Did that answer y'all's questions? Okay. So let's talk a little bit about the alternatives report in general. I know we've been talking a lot about loads and things like that in here, but the facts are, given the project parameters and given the resources that you've been provided, you should have enough right now to at least rough out your alternatives, to get a general idea of what alternative 1 looks like and what alternative 2 looks like, and that from then you should have a general idea of how big these elements are going to be, how much they're going to cost. Like, I have no problem if you're using old similar bridges or online resources or something to try and guesstimate numbers of bolts and things like that. I have no problem if you're doing that now. I really don't. As long as you're able to come up with, you know, a cost and schedule for this, a cost and schedule for this, like why you're evaluating one alternative versus the other. So I'm curious if, because like I said, I'm going to try and do my best to try and take a little bit of a break from this super heavy theory discussion, because at some point y'all got to get a report ready. So I want to see what you all think you need in terms of getting that report where it needs to be. Like, I'm just curious. Has anybody got an idea off the top of their head? Like, do you have what you need now? Do you need to think about it? You know, because one of the things I was planning on doing on Friday is I'd like to hear another report from each team as to where they're at verbally. I'd like to hear where you're at, what questions you have, what you need in order to move forward. So. Mm-hmm. Essentially, like, and what I mean by the schedule is this. Look, I'm okay if your schedule is, and I know that you might not like this answer, but I'm okay if your schedule is super, super rough. We think this bridge is going to take about 12 weeks to complete. We think this bridge is going to take about 6 weeks to complete. We think this bridge is going to take about 14 weeks to complete. I have no issue if the schedule is really rough, if, let's say, your cost estimates are just so ludicrously far apart from one another. You know what I mean? Because, you know, if you have one bridge that's $200,000 and one bridge that's $500,000, and the rough schedules only say there's a couple weeks difference between the two, if I was in your position, I'd go with the cheaper bridge any day of the week, right? But if your cost estimate is within $5 of one another, well, then you're going to have to come up with something else, some other reason why you're going to pick one bridge versus another. Like, I don't know what to tell you there, other than that's just the facts. That could mean, it could mean the construction schedule. It could mean other things. It could mean transportation limits. It could, you know what I mean? It could mean labor costs. It could be any number of things, but you need to justify it. You can't just say, well, I have this bridge that's going to cost $200,000. This bridge is going to cost $200,005. So we just went with that one because it's $5 cheaper. Like, your estimation capabilities are not that good. I don't care who you are. So you have to come up with something else. Now, if the cost estimates are so disparate that a rough, well, we think this is going to be about 12 weeks, this is going to be about 14 weeks, that's fine. You are going to hone in on a more detailed schedule with your final report. So I don't have any issue with it being really rough now. I really don't. However, let me also say this. That does not mean that, well, we're just going to make the numbers work so that this bridge is 300 grand more than the other, regardless of whether or not it works. I've been doing this for a while. I know how much these bridges are supposed to cost, so don't do that either. So, yeah, during your alternatives presentation, yeah. Oh, yeah. No. You think, but that wouldn't happen. But that wouldn't happen in a bid review meeting either. At the end, I will. I'm not worried about it now. If I make you a deal, make you a deal, make you a deal. That I'll tell you what. It's a reasonable question. The Monday we get back from spring break. That, because I'm not as concerned about it right now. Okay. Monday, is that fair? Because I don't think it's relevant now. I don't. But I'll show you later. I will show you. Yeah. Go ahead. Go ahead. I'll throw you that bone. We'll skip the Gantt chart for the appendix for the. But let me qualify that statement. Let me qualify that statement. Let's everybody pay attention, and I think that this is a fair way of going about it. If your numbers on your cost estimates are that far off, 200 grand versus 500 grand, I'm not worried about a Gantt chart. But if you're doing your math and they're just too damn close and you need a little bit more refinement on your scheduling, we might move that Gantt chart lecture up a little sooner. But only if necessary. If not, we'll worry about the Gantt chart until later. And if you need a Gantt chart, just put it in the last appendix. The appendix, well, it says E, but it'd be appendix D, and just call that miscellaneous documents and just put it in there. Okay, hold on. Nobody at Huntington? Really? What? Are they like? Tell me what you like. Describe that a bit. Like, what's going on? But you haven't called back. I mean, I'm like, tell me what's going on. So. Okay. Who? Okay. Let me see what I can do about that. I'll see what I can do about that. I've got some resources that I can use and some other places that we might try and contact. If it comes down to it, though, at this point, we can adopt just a cost per pound and then multiply by the number of pounds to get a raw material cost, and then we can take RS mean crew costs on labor to get a labor cost and equipment cost. So we can get by without it. So give me a couple days. So now you, and then because he had his hand up first.
How do we go about justifying where certain numbers come from? Like for example, I know a bridge engineer at the DOH, and I've asked him a few questions for things that I just couldn't find. He said, "Oh, you should probably do this, or it'll probably take this long," and that's kind of what I'm rolling with.
Cite it.
So how do I go about citing just his word of mouth?
Put his name down. Put his or her name down.
Okay.
I mean, that's fine. I don't have an issue with that. It's not that uncommon in professional. I mean, look, the best thing to do would be send them an email, and then include that email in your correspondence in your report.
No, I got it. For like a timeline of construction, things like that, do we need to go ahead and consider how long it's going to take to manufacture or whatever type of game that we use, or do we assume that we've already called that ahead of time? We know that it's going to be ready when we're ready for it, so it's just going to be basically the date, the time it takes.
Are your two alternatives going to be different? Then the short answer is yeah. But again, that consideration, I can't stress this enough, it can be rough if you have another solid means of evaluating why you're going to pick one alternative versus another. But yeah, because, look, the best thing, what you want to do is make your case. Okay, that's really what I'm sort of boiling this down to. You have alternative 1, alternative 2. You need to convince me why you picked one versus the other. Okay, so if the cost is just that much different, as long as you've at least looked at the schedule, I'm fine. But if the costs are close, then you got to tell me why. So.
You're saying like the cost is that much different. Go off that. But what if you have one that's a lot more labor intensive, so your cost is based off your estimate?
But the costs will. Well, now I'm confused. So are you saying that you've got two alternatives that cost the same, but the costs are generated differently? Like one is cheaper on material, one's cheaper on labor. Is that what you're saying?
Right. So it's based off our labor. Like what if they're significantly different, but one's heavily labor and one's heavy labor?
Then you probably need to look at time, because a labor-intensive project is going to probably have a different time of completion than another. So if the costs are largely identical, see, you could, like, let's say you're having a difficult time on scheduling, and I can understand that. But what you can do is take an RS means, let's say, crew rate, right? And so you've got a crew that will produce X number of square foot of slab per hour. And so you can take the total square footage and say, okay, that's how long it's going to take for this crew to do this, and that's how long it's going to take this crew to do this. So if the two costs are identical, then you can go into the weeds a little bit to at least kind of have an idea. Well, let's say we were talking about just the slab. It's going to take this crew, 6 days to tie the slab and pour it, whereas this is a precast section, so it's only going to take 1 day for them to sit it down and pour an overlay. You know what I mean? So in that environment, yeah, you probably are going to have to go into the weeds a little bit to try and define that. But if the costs are identical and there's a third parameter that we're not talking about, like there's costs, there's schedule, but what about, I don't know, transportation? What if you can't get the girder down the road? Well, that sort of does it for you. So, yeah. Does that make sense? Well, how about everybody else? How you feeling? This is about when that starts to happen. I know. Yes.
Are we supposed to produce site dollars for all alternatives?
It can be rough, but yeah. For the final report, I'm going to expect them to be a little more detailed, because then you'll know what you're working on. So. It'll depend on your alternative. The reason why I say that is if it's a steel bridge, then I'm going to need things like stiffener spacing. I'm going to need the cambers are going to be might be defined a little differently. Whereas, let's say if it's a pre-stressed bulb T, then I need a strand profile, and it's not the same story. So it depends on the alternatives. That's why I'm waiting. So it can be rough, but it needs to be accurate is all I'm saying. Like what I don't want, and you want to talk about the real mistake that teams do? The report will say it's a 14-inch wide flange and the drawing says it's a 16-inch wide flange. That stuff happens all the time because you're changing things up until the last minute and the left hand didn't know what the right hand was doing, and then there's that. That's the stuff to be honest, that's the stuff I get y'all on, is stuff like that. So. Feeling nervous? That happens right about now. I know. I believe in you. I know you can do this. I've been through this before, and I've had just as many students succeed. That I know. That's
Why are you saying it like that? Why are you doing this?
that's by design a little bit.
Get out on a piece of paper.
That's by design a little bit. This is supposed to be open-ended. It's supposed to be a little disorganized. You've never had anybody at work that you've worked with? You've never had projects?
I stand
At the Corps of
around
Engineers.
and I walk around.
Okay,
Don't forget to say at the Corps of Engineers.
No, I'm not, no. I have a student who the first 2 years of my work, I scanned stuff and worked on little things. Now what I'm doing is a little different, but I just work with one person. My whole group. I'm not that needy yet.
listen, let me explain why, and I'm gonna address this question before we leave because I do want to mention that. Let me address that. The facts are, in our profession, not only are you going to be working with different entities within your own company, but you're going to be working with different companies. For instance, a typical design, bid, build project is going to have a lot of different entities coming together. You're going to have an owner agency like the DOH. You're going to have a consulting firm who designs. You're going to have a construction company who builds. So there's going to be a lot of different components coming together. And if you think that every project has perfect 100% communication every time, that doesn't happen. And things do change at the last minute, and requirements do get adjusted. And so this experience is meant to be a little chaotic, and it's meant to be stressful, because I'm trying to put you through this now so that when you get out of here and you get into design office land or construction company land, that you've been through it before. And so a lot of what I'm doing in here is actually kind of based on experiences I've had. Like, I've been through this stuff before for real, you know. So I'm not doing it because I'm trying to make your life a living hell. I'm really not. I'm doing it because you're going to go through this. I'll send it. Now, to answer his question, and then we're going to leave, he asks, has anybody failed this class? I'll say two things about that. Number one, it's been rare, but it's happened. But what really happens a lot more commonly than you would think is you'll have team whatever, team 7, everybody gets an A, but this person gets a C. And they get all upset, well, how come I got a C and everybody else got an A? And I'm thinking, well, do you remember those evaluations that you sent me? Remember those? Well, let's put it like this. I've had teams where I've had a member literally not contribute to anything. And so what I'll do like this. See this? This is your final report. I want you to point in here and tell me what you did. And they look at me like I've grown a third eye or something out of my forehead because they can't answer the question, because they didn't, So you see what I mean? So that would be sort of my answer to that question. That is rare, but what is more common is that if you don't participate, then you're not going to be evaluated equally among the peers in your group. That is going to happen. I'm just telling you. So, which is why I take these team member evaluations seriously. I'm not trying to be the guy who dumps on you, or I'm not trying to encourage this retaliatory response. I just want you to be honest. Because the way I look at it is, I don't want you to be penalized if you've been busting your hind end and everybody else on your team is, too busy with Fortnite. That's what I'm really concerned about. I'm trying to defend those who've actually been busting their hind end. So, that make sense? Friday, I want a report from everybody, and I want to have a little bit more of an engaged discussion, and then we're going to discuss our schedule between now and when the alternatives report is due. So that's all I got.